on neonatal infection, I could not present what she's doing, but this is really, I think, quite exciting. Cindy Fèvre, she works on organoids, as I told you. Camille Blériot works on the liver phase of the infection. Yuan, very talented PhD student, works on neurotropism, and there is a lot of going on here. We try to identify this gene I told you about. Grégoire Gessin, another PhD student, is working on the intestinal response to listeria. Charlotte is an M2 student. And now to really finish, I want also to acknowledge the reference center on listeria, Alexandre Leclerc, who manages the center, Viviane Chenal-Francisque, who is an engineer and helps Alexandre and also develop a research project, Caroline Charlier, who is in charge of this Mona Lisa study, and now the technicians, which are Hélène Dieye, Morgane Lavina, who just arrived, and Anne Morvan. And here you have Magat Fall, who is involved in this Mona Lisa study. Now there is a long list of people who are continuing interaction and fruitful discussion. Many other people from the immunology department I would like to name, maybe Gérard Hébert, Jim Di Santo, also Ivo Boneca. We work on the intestine and on this interesting immunology kind of phenotype. Geneviève Milon, who taught us about these liver macrophages and so on. I won't name everyone. Now, I would like also to finish by acknowledging Olivier Lortolari, who heads the Service des maladies infectieuses et tropicales at the Necker Enfant Malade Hospital. And thank you for your attention.
Merci Marc. Est-ce qu'il y a des questions dans la salle? Je vais apporter le truc.
Celui-là, il marche. Je crois qu'ils sont là.
The question is simple. So now that in your model there are only vesicles, where are the actin comets that have been so famous to...
I didn't hear the question.
The actin comets,
Yes.
comets that are made by Listeria and
Yes.
that had made so many nice reports. Where are in your model now that we only see vesicles and transcytosis, and even in the epithelial cells you also put vesicles and the recycle. I love vesicles, but where are the actin comets?
So there is no, during the early stage of translocation, as I tried to convince you, there is no requirement for actin comet tails. Indeed, the movement of Listeria is not based on actin-based motility. This is certainly not to say that these actin tails and actin-based motility is not important. As I said, if you remove ACT-A, you have a very strong attenuation in virulence, and we believe, although this is not completely proven in vivo with a genuine observation, that these comet tails are indeed implicated in the escape from phagocytes to neighboring cells. We have obtained, I should say, Jean-Pierre Levrault has obtained interesting results in zebrafish, where he could show that the ACT-A mutant and the LLO mutant are strongly attenuated, and that clearly the phenotype that they have in these phagocytes in zebrafish is not the one of the wild type. So we believe that the vacuole from which it's important to escape when you are Listeria is the vacuole that will kill you, which is that of macrophages. The vacuole from epithelial cells won't kill you, so why would you leave this vacuole? That's our interpretation. And also we kind of know, I didn't go into the details, why is it that they don't escape the vacuole in epithelial cells?
Thank you. Great, Mark. So I have a question on the liver infection of Kupffer cells, actually. So first, I believe that this must be a phagocytic event, that the Kupffer cells are taking up Listeria. So first question is why? are they exclusively taken up by Kupffer cells, not by any other liver-resident phagocytic cells? There are dendritic cells, for example. And second, because the liver is